query matrix with condition. You given passing integer because given the rows, conditions, and constructed. Let's do this first problem. We're given the integer arrays less than, and given the queries less than, return the answer less than where answers I is the maximum size of subsequence you can take from numbers. Size of subsequence, that sum of elements is less than or equal to. Okay, so first, for each query, calculate the maximum size that you can insert numbers for each query. Try to calculate I'll just say Q. So we start these. Even about X. G++. Reese. That's it. First problem. Remove star from strings. Given a string which contains stars, in one operation, choose a star. Remove the curses not start is that as well removes that itself. Right, so lead will erase E. Right, just ideas. Do from left to right. Classically is linear. So we have a string. So if C is star, yeah, that's it. Minimum amount of time to collect garbage. You given about 0 index substring garbage, and garbage represent the house, so consists only MPG. So 3 1 unit metal, paper, and glass garbage. Pick 1 unit, take 1 minute. Alright, so a trouble is the numbers of meaning that need to I to I plus 1, so this need 2 minutes. What it means? Minimum numbers meaning pick out all garbage. So, alright, so we have the paper garbage. We will 2 minutes. Travel from house 0 to house 1. Cover. What is the length of the 10? Okay, so it's 10. Calculate the minimum time that to collect or garbage. Right, there's 3 pass. Each pass is calculated. Or constraint garbage. Calculate. So we also have a calculator. Is pass and let's say the paper garbage. So we traverse to 1 and take 2 minutes, and get 3 minutes. 7. Collect at 1. Traverse from house 1 to house 2. They do not need to visit every house. Okay, so what it means? Only one garbage can use me at the moment. Oh. Wait. I misunderstand the problem. Okay, look carefully. So pick 1 unit, take 1 minute. So pick 1 unit, take 1 minute, and need to go to from house I. So we need alright, so So in the first case, the paper garbage will traverse from 0 to 1. That will take 2 minutes. Collected. Extra minute. Minute and 4 and collect is 8, so we don't traverse because we don't have anything. Right, so we don't have anything. Okay, and so basically we are in 0 here, and garbage still need garbage size. Garbage I, and basically we calculate the bottom character. So if count, that we will add about the time. This is travel time. The time now going to be 0. Right, so yeah, that's it. Garbage size. So we calculated, we don't need to traverse, only traverse the count is greater than 0. That's it. Okay, so build a matrix with condition. What it means? Class name with K is that we want to build a K times K matrix that contains each numbers 1 to K exactly once. So for example, okay, remain cell is going to be 0. So we have 1, 2, 3, right? And we also have above is going to be what it means. A real condition will be above and below. So what is that? in each row. Should satisfy the conditions, and row conditions is that in the what it means. I is I square, so I don't understand. The above appear in row 3 above when the number below appears I. Left appear in column 3 left to the column which is number right appear. Return empty. What kind of? So we want to build k times k matrix, right? And yeah, and we also have a row condition, the column condition. So in this case, we say in each condition we will have below, above and below. What is above and below? I don't understand this condition mean. Well, let's see the example problem statement and understand what these two conditions. So okay, so above should be appear in a row. What it means? So basically, the diagram above is now the row conditions following numbers 1 in the row 1, numbers 2 in the row 2. So 1 is above. Above 1. Oh, alright, so number above should appear in a row, stringer above the row which is numbers below. Appearance I. Alright, so this is something like the condition is 1 is above 2, 3 is above 2. So what is the minimum above? It's going to be 2, right? Now we know the 2 is in the last I. We don't know. So something like a graph problem, right? So let's say 1 is greater than 2, 3 is greater than 2, but we don't know the 1 and 2 conditions. So 1 and 3 can be swapped, right? So that's a row condition. That's a row condition. And what about column condition? It's 2 is left and 3 is left and 2. So the leftmost is 3. So now 3 is going to be 0, and 2 is going to be 2. 1 is going to be 1, and this should be 2 is going to be row. And if empty, I mean a sink is have a cycle. So we're starting from in degree. Or we say 1 is more than 2, 3 is more than 2. Right, so if in this example we say 1 should be smaller, 2 should be smaller, so let's consider a cycle, right? Okay, so there's view the graph, do top logic, and let's say 1 is smaller than 2. Now the integrate is 0, and right, so we can combine to the operation. So now I want to build a graph. Right, so we still have integrate. This is graph, and this is integrate resource. And now we build a graph. So I want to do separate graph. This is the graph, and this is also another graph. Right, so we only consider row condition, common condition independently, and so build graph. Now I'm going to do row conditions. So 1 is smaller than 2, right? So one is more than 2. Now it's integrate 0 at 1 graph. Yeah, and I just did it. Now we're saying that which integrates 0, so this is 0. Right, so we also have a row. So row K is the key row. let's just do it. And now we are seeing that I have a cube. Cube size, say this is maximal, so it's going to be k-1. Should be row index from a greater. So last row. Zero means that you push this index. Let's compute about a row. Now this should be the last row, so let's say row U is row ID. Right, so so with count row now visited. So we do it again. This is the column. Now resource is row and the column should be here. Yeah, that's it. Want to see out the row. So U. Two, 1, 0. let's just column. Yeah, I think this should be work. Row 210, and we don't have any integer 0. Why? Because 1 is going to be 2, 2 is going to be 3, so 1 is going to be integer I is 0, and why we are not have this case? Because wait, and 1, because 0 is 300 001 020. Yeah, that's it. Yes, alright. Still waste so much time to do this problem. Yeah. Alright, let's talk about the problem. So this problem is that you are given the limit, given a query, and you want to find out that what is the maximum size of the subsequence such that the sum of an element is less than or equal to query I. So for example, the set 3, we can add 1 and 2, right? Because the sum of the subsequence is less than or equal to the 3. And what about 10? 10 we can add this 3 value, right? 1 to 5, and we can get 10. So idea is that because this is a subsequence, so we don't consider the order. We can sort all the value, and for each query we can try to choose the smallest value, and until the sum is greater than the query value. So I just use the calculate function to do that. Is the until the sum is greater than x, and want to know how many numbers that is equal to the how many numbers that is in smaller than x. Yeah, so let's just use a while for loop, and we add a sum until the sum is smaller. When the smaller, we add it. And actually this is linear, and we can use binary search to improve the algorithm. How do we do? We can use prefix sum, and we can binary search the prefix sum such that what prefix is greater than x. Choose largest I, that prefix I is smaller than x. We can binary search it because the prefix sum is increasing. So it's as a sorted array. This prefix sum is as a sorted array, so we can use binary search to improve it. But in this constraint, we can just brute force it because the queries is small. Yeah, that's a problem 1. And what about problem 2? start. Well, on this problem, actually, it's that when you contains a start in one operation, we choose the start and choose the closest non-start character to its left. Actually, in this problem, you just simulate from left to right, and when you encounter a start, so when you encounter to start, you just erase the last element, right? Because this is the closest non-start characters, because we don't have the start itself, so actually this string is always be non-start element. Yeah, so we just do from left to right, and we build about this is a non-start string. We don't have any start in this resource, and then when we have a start, let's just remove the last element, so we just pop back. Otherwise, we add the character, so the time complexity is linear. It's very simple. The space complexity also be linear. Yeah, so that's problem 2. And what about problem 3? Alright, so this problem is more problem statement is very a little long, and you have a garbage, and the garbage represent the assortment of garbage at the ice house, and the garbage I only consists the letters MPG, and list trees is the different type of garbage, and we pick out 1 unit of that type. We will take 1 minute, and we also have the trouble time between the I to I plus 1. So and we also, in this problem, we must do visit each house in order. We cannot skip the house, and then but we can ignore the house, because if we don't have garbage, we don't need to visit that house. So yeah, and addition condition is that only 1 garbage trunk can be used at any moment. That means that we cannot parallelly do the 2 truck in the same time. So we must do we must sum it up, sum the garbage, each garbage truck. We do separate it. So the idea is that, or let's just talk about example 1. So the garbage is, we have 4 houses, and each house has this garbage G and P, GP, GG, and well, this is 21 because we traverse from 0 to 1. That will take 2 minutes, and when pick up 1, so 3 minutes, and we traverse to the next house will take 4 minutes, so totally 7 minutes, and pick up 1 unit of the paper, so that take 8 minutes, and we don't need to traverse to the GG because we don't have paper garbage in this house. So what is the idea? We do separately, and we just simulate it. For each calculate, this is calculate 1 type of garbage, and we also use a return, and so for each type of garbage, let's just traverse from left to right because we must do in order. And when we get a string, we calculate how many garbage how many garbage are there in this house, right? So yeah, if the house we don't have anything, we can skip. But if we have the garbage that we should add the travel time, because the approach I do here is that we only calculate when we have garbage. We only calculate the time when we have garbage. So and actually we always have a traverse time. Travel time, but we don't actually add to the resource because we don't really necessarily visit that house, so we don't traverse to this house. So we just add it to the backup for backup, and after we add the garbage, we will clean up the travel time. Cleaning up travel time. So that's a trick. So it's like a lazy calculated. So we add the time, add the count, and clean up the time. Yeah, that's it. So we do 3 parts. We take linear. Yeah. So and about problem D, it's not a hard problem. It's but the problem statement of the row conditions is ambiguous, I think. But yeah, so for this problem, you want to build a matrix of a k times k matrix, and that contains the 1 to k exactly once, and actually in this example, let's just see example 1. We don't see this condition. I think this condition is no use for me. And if we don't satisfy the conditions, that means the no answers exists, return an empty matrix. So in this example, we have 1 and 2. That means that this condition means that number 1 is smaller than number 2. The row is above in the number 2. So you see this answer example, you say, oh, 1 is above in the 2. 2 is below in the 1, right? So we have this condition and we can treat it as a directed graph. And also we do current condition as a directed graph. What should we do? We just do topological order, because the 2 if we have a determined node, that means we can put the node to the first row. And we don't have a determined node. That means if the integrate of a node is not equal to 0, because integrate over a node is equal to 0, that means that this is a root node. For example, say 1 and 2, we can build 1 smaller than 2, 3 smaller than 2. So 2 has no integrate, so 2 can treat it as a root. So we're starting from the 2 and why the traverse to 1 and 3. And 1 and 3, the row conditions doesn't matter because we don't have a condition between the 1 and 3, so we can treat them as any order. So let's just do separately row condition and color condition and build a matrix. Yeah, and let's answer. So we build the row is that I want to talk about my approach is that we build a graph and do the topology each condition, and after we do the topology, we will get a number is in which row or a number is in which column. So we do separately. We build a graph and calculate the integrate about a row. Let's say integrate 0, 1 and 2, 1 have the integrate 2 going to 1, 3 2 going to 3, 2 going to 1. So 2 will push back it. And we're starting from integer 0, and what we try to do is that in this case, that means that they are finished node. So finished node, we just put the row because we're starting from the last element, the largest row condition. So we're starting from the last element. So I just do traversal grab and minus the integer, and we see if integer 0 we put in the queue. That is the topological sort. And how we check if we don't have satisfied the condition? We just check that if we have any unvisited node. What it means unvisited node is -1. -1 means that a -1. -1 means that we don't have traverse in this node. If a row k is going to be -1, that means that the k is not in the queue and should be returned empty. So I just do twice. Yeah, and actually this can be simplified to. Yeah, this can be simplified. And after we build row and column, we construct a resource in the proper row, correspond column assigned to current value. Yeah, that's it. Okay, so problem D. Alright, that's it.